Okay. In software engineering, data plus whatever we write a program, which be conditions. Data will have the data, plus we will define the rules, if conditions, else conditions, and everything. We will manually write it. And this will lead you to the answers. This will lead you to the answers. Then, whatever. Hello. Here, data with conditions will lead you to the answers. What is the difficulty? Difficulty is maintaining the maintenance of the rules. If rules increases, your program becomes more clumsy. Clumsy. Your program looks more clumsy. So that we don't want the rule-based programming rule-based approach at all. We want AI-based, where we give the data and answers. It generate the rules. It generate the rules. It generate the rules. Clear, Asia?
Yes, clear, sir.
So ML effort allocation. This is the one where we build, where we spend more amount of time in the building of ML application. First is defining of KPI, collection of data, building infrastructure, optimizing ML algorithm. This much of the effort we are going to put it. And integration. Integration part is small part. But reality is, this is the expectation. This is the hard reality. Integration will take more time. Building infrastructure, optimizing ML algorithm will take the less amount of time. To build the machine learning models in the production, identify the goal or problem statement. What we need to do? We need to acquire the data. So this comes under the data science life cycle. Which starts with the problem statement, which starts with problem statement. Then we collect the data, we choose a model, we train the model, and we evaluate the model. Then finally deploy the model. Deploy the model. This is the life cycle of the. See, whenever you want to build a model, whenever you want to work with machine learning, we need to have a problem statement. What is a problem statement? Problem statement is something that predicting of a house prices. Let us take a problem statement. Let us take an example of problem statement. Predicting of prediction of sales. Prediction of the sales. For that, we will get the sales data. We will get the sales data. and we will choose the model selection. Then we train the model. Then we we assess the model. We evaluate the we evaluate the model. Then we create a endpoint and we deploy it. Then we deploy it. So can you see here? Identifying of a goal is nothing but selecting the model. Sorry, am I wrong? My miss. Selecting the problem statement, taking the problem statement, acquire and explore and prepare the data, build a model and train the model, evaluate the model, and deploy, monitor, and maintain. These are the things we do in the typical machine learning lifecycle. Typical data science development program starts with framing of a problem statement. Ideally, what happens in the problem statement? Problem statement is most important for your data science. Well-defined problem, well-defined problem has 100% solution. Can give me some insight on this statement? Can give me the insights of this from this? Well-defined problem has the 100% solution. Guys, I'm asking you only. Karthik, Pushpa, Kirti Kalyani, Soumya. What did this statement means?
Sir, can you please repeat your statement once again so that I can.
Well-defined problem has a 100% solution.
So well-defined problem like something like what do you say? A structured data is we'll have the understanding of what exactly need to be done, and based on that we can have the output.
Yes. We should be clear on the we should be clear on the question, the problem statement. Problem statement. What we are going to solve. What we are going to what we are going to what we are going to solve it. If you have this clear statement, then you can build a better model. You can build the model. This is the problem statement. Framing of a problem. And next stage is preparing of a training data. As we discussed, we need to collect the data like sales data, and we that is the one. Experimenting. Experimenting is nothing but you are choosing the model A, model B, model C. Whatever we do here, model training. We train different models, but we take what is the best accuracy, what is the top of the best model. We won't build a single model, we need to build multiple models. We need to build multiple models. Multiple models. That is experimenting. Experiment model A with random forest, support vector mission, logistic regression. We will build it. Then finally, we evaluate the models. See, evaluation metrics are the evolution of the model. See, evaluation metrics tells us how good your model is, how good your model performance is.
सर्टिफिकेशन के लिए कोड और ले रहा हूँ ये इसको थोड़ा ठीक कर लें जुलाई महीने में कुछ अचीव कर लें
Sir, can you go on mute, please? Kapil, sir. Then evaluating the model. Typical data science have the different architectures, different CNN. Yesterday we discussed about whenever you have the unstructured data or structured data, you are going to choose the different models. Then you have the different architectures, CNNs, RNNs. These all are part of deep learning and different input data sets, numerical data set, bivariate data set, multivariate data sets. We all these points will be discussed in the these points will be sorry. These points will be discussed in the statistics class. Productionizing the productionizing the productionizing the ML application by using what? Fast API. We any ML application has two layers. One is front end, another one is back end application. Back end, front end is Java application, Java based application, and whereas back end is the your AIML application, which connects the which will send the request from front end to back end to front end. So where we create the REST APIs, where we will create, where we will connect using this REST API. REST APIs. We'll have this one. Guys, till this point, are you clear? Type 1 in the chat window. Everybody, I need everybody's contribution. Here, ML application sends the request and prediction will be your example. We are going to send age, gas station, weeks, and gender. It will send you, it will predict you a prediction capability. This is the prediction of the application. Package, deploy, and moving the experimentation to the production requires packaging and deploying and monitoring. We will touch base here. Whenever we build a model, we need to package it. And we use the pickle files. Pickle file for ML applications. ML application. And where we need to deploy in the cloud environment. Where Nana? Cloud environment. What is the advantage? What we will get When you deploy the in cloud environment, we will get the endpoint. This will be consumed, then we need to monitor. Per model performance. Model performance. So these are the use cases. In the manufacturing, we will see the use cases. In this in manufacturing, we have predictive maintenance or condition monitoring, warranty reserve estimations, and prosperity to the buy, and demand forecasting, process optimization, and telematics. In a retail, we have the predictive inventory planning, recommendation engines, upsell and cross-sell channel marketings, market segmentation, and the targeting, and customer ROI, return of investments, and the lifetime value. In the healthcare sectors, we have alerts and the diagnostics from the real-time patient data, disease identification and the risk satisfaction, and the patient triage optimization, and proactive health management, and the healthcare provider sentiment analysis. Travel and hospitality, aircraft scheduling, dynamic pricing, social media, customer complaint resolution, traffic patterns, and congestion management. Whereas in financial analysis, where your most of AI being used in the financial sector, where to identify the risk analytics and the regulations and the customer segmentation. The most important ML application is the customer segmentation and the cross selling and upselling and the sales and marketing campaign management and credit worthiness evolutions. The credit worthiness evolution means that if a person goes to the bank and based on his data, it has to understand and estimate the his worthiness, whether he is a potential customer that he can repay or not. And energy and feedstock and utilities, the power of usage of analytics, data pre-processing, carbon emission, customer specific pricing, smart grid management, energy demand and supply optimization. Google infuses the machine learning in almost all products. Google Photos illustrate how far ML has come. In a Google Photos, it will tag your relevant photos to your. It groups you the images together of the same person. And Google Translation and Smart Reply in the Gmail. Whenever you get an email from somebody, when you reply it, it will give you the smart suggestions to write it. Machine learning phase, the training phase, we get the label data, then we choose the ML algorithm, we train a model, sorry, we train the model, then we serve the model. Whenever the new data comes, it is going to be predictions. Typical flow, we take the data, we train the model, we train the model, we'll get the model pickle file. Remember this PKL file. This is used for predictions. There are two stages. Two stages in ML algorithms, ML or DL, anything, AI. One is training phase, another one is predictions. We train a model whenever we get the new data. Whenever we get the new data, we use the predictions, then we generate the output. Is this clear, guys? Typical flow? Yes, no? ML pipeline, staging and pre-production and production environment. When you take the raw data, data collection, data analysis, data preparation, model training, model evolution, model validation, and the model registry. Here is the model registry, trained model and serving model. And the prediction service, performance monitoring, and again, if it is not good, then it goes to the data analysis, then it will follow the process. This is an iterative process. Data science life cycle is an iterative process. So whenever that ML structure, right? Whenever you are building the ML solution, the core component is data collection, data extraction, mission resource management, feature engineering, ML code, analysis tool. But your serving infrastructure is become more. This is the core component. Okay. We will see machine learning, some basics of machine learning, then we will go to the next demo session. Machine learning concepts and use cases. Typical machine learning will have the three roles, three types of category. One is regression, another one is classification, another one is clustering. In this, there is a supervised learning we discussed yesterday and also unsupervised learning. The regression and classification falls under the supervised learning, whereas clustering falls under the unsupervised learning. Predicting a number. Regression is nothing but predicting of a number. The classification is predicting of category. Clustering is find the hidden groups. What is machine learning? It teaches the computers to learn from the data, not the rules. Today also we discussed about machine learning is a typical different software programming which learns from the data and which create the rules out of it. The machine learning is a branch of AI system where learns the patterns from data and improve the performance on a task without being explicitly programmed with rules for every scenario. What is this, Nana? Without explicitly being programmed with rules for every scenario. You give it an example, it learns from the underlying patterns. So learns from the data, trained and historical examples. Improve with experience, performance is getting better as more data is seen, find the patterns automatically, detect the relationships in the human might miss, make the predictions and decisions, apply the learned patterns to new and unseen data. We have the three core types of machine learning. Yesterday also we discussed supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, it learns from the labeled examples to predict the output of a for a new input. Regression and classification finds the hidden structure and grouping of unlabeled data. We discussed right. Unsupervised learning is unlabeled, non-labeled data. Reinforcement learning is the learns by the trial and error, guided by the reward and penalties, game paying agents, and the robotics. We discussed about in the previous slides also machine learning workflow, collect the data, the from raw data to real world prediction, 5 key stages: prepare the data, train the model, evaluate the model, and deploy the model. What is regression? Predicting the continuous numerical value. Regression is a supervised learning technique which predicts the continuous numeric output by learning relationship between the input and target variable. You give it the numeric examples and predict the numbers. Regression is this is the regression line, fit the line and house price and regression line predictions. These are matching. This is the predicting of house prices. When you can see that use cases, whenever our answer is number, the regression can help. House price predictions, sales and demand forecasting, and insurance premium estimation, stocks and financial forecasting, weather forecasting, and energy consumption predictions. These are the use case for the regression. The classification is supervised learning technique that assigns the input data to the several predefined categories by learning boundaries and separate the each classes. So it separates the two classes. It separates the two classes. Label data learns from the boundary. Here you can see that it is able to make the difference between both the sets. There will be a misclassification, that is the error, and classify the new points side of the boundary and predicting of a class. Use cases for classification is email spam detection, image and object recognition, fraud detection, customer churn prediction, sentiment analysis, model diagnosis. These are the use cases for the classification. The clustering, what we need to do, right? Clustering. You give the raw data and it discovers the natural grouping. Clustering is an unsupervised learning technique that groups the data into clusters. You can see, right? Grouping the points by the similarity. If we are separating into it's by the nearest approaches by using the centroid mechanism and the distance metrics. It calculates the distance of the each metric and it assigns to its centroid. Customer segmentation, anomaly and fraud detection, document and topic grouping, image segmentation, recommendation grouping, and genomic sequence clustering. Now you can see here in this tabular. Can somebody read out this? Regression, learning type supervised, classification is supervised, clustering is unsupervised. Output will be what? Continuous number. This is discrete category and the group and clusters. Need a labels? Yes. For classification, yes. For clustering, we don't need the labels. Linear regression, logistic regression, SVM. Here K means clustering. What is the price? I'll go with the regression. Which category? I'll go with the classification. What is the group? exists, I'll go with the clustering. Predicting a number, use regression. Predicting category, use classification. Finding the group, use clustering. This is the one. Let me go and show you the demo of machine learning application. We are going to build a machine. We are going to see the demo of machine learning application of here I'm using the DeepSeek algorithm. I'm using the generative AI also, and where we are creating the file, where we are splitting the data and scalar training of the model. We are training all the models using logistic regression and the evaluating the model and the accuracy report and fairness explanation. This is the one we are going to do. We are going to use case. We will discuss some use case prediction of defaulter. Defaulter. Whether this person will be defaulter or non-defaulter. When you see this data set, I will go and open the data set. Loan default. Here we have the loan amount, credit score, and months of employed, and the number of credit lines, interest rate, loan term, education, full time, marital status, has mortgage, has dependents, purpose, and has a cosigner. These are the ones. And we have whether the default is 0 means no. 1 means yes, either he is a defaulter or not. So this is the age, and the here we'll have the data. We'll have the data. Based on that, we are going to predict the model. How many records we have? 2,55,000 records. 2,55,000 records was there. Now we will go to this. The we will select the machine learning and we are going to upload the file loan default. We will see this loan ID and everything, employment type and everything, default or anything. Select the target variable. What is our target variable in this? The target variable is default. Default. Your select the sensitive feature to fairness because I want to understand whether age is the factor that is becoming default or not. Based on the age, I am going to pre-process the data and everything. టైం పడుతుంది లేదే
एफएनओ ट्रेडिंग अगर सही से करनी हो तो सही इंफॉर्मेशन होना भी बहुत जरूरी है, तो इसलिए मैं यूज करता हूँ ग्रो ऑप्शन चेन से अपने ऑर्डर्स डायरेक्टली प्लेस कर प्लस
ఇది ఎక్కడి నుంచి వస్తుంది
जी बिजनेस की
Guys,
खबर
please mute yourself.
NIF के लिए
Here you can see the accuracy, precision, and recall. And this is the model accuracy. And also I'm planning the explaining the model. Model what happened and what this is what we are going to build it in our course curriculum. Our course structure, we will give you the more information about the algorithms. Here XGBoost and everything. Here it is generating the model. This is what we are going to build in our core classes. Any doubts, guys? Asya, Kapil. Okay. See you tomorrow, class.
Yeah, thank you, sir.